Okay, class, today I'm going to use something new, this crazy PowerPoint presentation, to teach you something new. Mathematicians, we're going to approach a new 5th grade standard today. But before we get to the new stuff, we're going to go old school. Like really old school. I want you to turn and tell your math partner, what's 3 times 1 and what's 3 times 10? Go. That's right. 3 times 1 is 3, 3 times 10 is 30. You're recalling your math facts. I want you to do the other 3 equations. Turn and talk to your math partner about the answers now. Yes, I'm seeing a pattern. Are you? I've put up all the answers. I want you to talk with your math partner about the patterns you see in the equations we've done. Wait, mathematicians. There's another way to write these equations. We can also think of it like this. 3 times 10 is 30. But instead of writing 3 times 100, I broke my 100 into tens. Do you see how I wrote 10 times 10, which is 100, right? And so I said 3 times 10 times 10 is 300. For my next equation, originally we had 3 times 1,000, but I broke that 1,000 into my tens. And 1,000 is 10 times 10, or 100, times 10 again, 3 tens. So 3 times 1,000 is 3,000. I did this one more time on the last equation I've written. Instead of doing 10,000, I broke my 10,000 into tens. I did 10 times 10, which is like 100, with Mrs. Dawes' amazing tech handwriting. Look at that. Times, oh, I can do it. Times 100. 100 times 100, 10,000. Times 3, same answer as before, 30,000. But wait, mathematicians, there's still another way to write these equations. And that is today's new big thing. We can use an exponent. I know, what's an exponent? Okay, the first thing I'm going to tell you about an exponent is that it's a mini number we can write in the upper right-hand corner of a number, like this. Okay, let me get my little pen here. I've given you some examples. I put an exponent right here. I'm using all tens today because we're talking about tens with exponents first. That's the first part of what we learn. So I put an exponent of a 2, I put an exponent of a 3, and I put an exponent of a 4. See how it's just a little number off to the side of my number? That's how exponents are written. Now, I know it looks pretty crazy, but let's see if we can figure out together how exponents work. Exponents mean what I've written below. Okay, let's take a really close look at what I've shown you. Right here, I wrote out the number form of 10 to the power of 2, or 10 with an exponent 2. It's really the number of tens I'm multiplying by themselves. So I have 2 tens here. Notice I did not write 10 times 2. That's 20. I'm writing something different. I'm saying 10 times 10, or 10 multiplied by itself 2 times, which is 100. When I have my exponent of 3, I'm really kind of saying like a shorthand code for 10 times 10 times 10. 3 tens multiplied by each other. Remember again, I did not say 10 times 3. That's 30. Okay, with your math partners, I want you to look at the next 2 examples. I want you to tell me the I want you to say 3 things. First, you're going to tell your partner what exponent you see and how many tens are multiplied by each other for that exponent. And then I want you to tell me a definition. See if you can use your math vocabulary and give me a definition for what an exponent means. Pretty good answers. We're getting there. I want to show you another way of seeing it. Remember a few weeks ago when we were talking about place value and we talked about how place values grow by a power of 10 each time we move along the place value chart? And we used manipulatives. So I thought I'd give you an image with manipulatives here just so you can kind of see it visually. And you can go back and picture what we were working with. So remember how we said that 100 was really 10 times 10 of these rods? Well, really, another way of saying that is 10 with an exponent 2, 10 times 10. And when we say 10 with an exponent of 3, we're really talking about these blocks here that are 10 times 10 times 10. This is important. When a 10 has an exponent, mathematicians, we call that a power of 10. So for example, when we see 10 to the third, we say 10 to the power of 3. So for the equation I have below, we would say 3 times 10 to the power of 2 equals 300. Okay, I know this is a big new thing. Let's try to put it together. Here's what I want to do. I have given you some equations where I've gone back to what I talked about at the very beginning where we played with our knowledge that we have really solid, our 3 times 1 and our 3 times 10 and our 3 times 100. We know all those things. So I want to take what you knew before and I want you to think about what we've just explored with exponents and talk with your math partner about the answers you all think would be correct for these equations. Go ahead and share that with your partner. That's it, mathematicians. We've learned something new. This week, we're going to master the 5th grade standard of using whole number exponents to denote powers of 10. I know it's new. I know it's just the beginning, but based on what I've heard you talk about with your partners, mathematicians, let's do this.